We turn now to our first example. What we're going to do is find the integral of 1 over square root of 1 minus x squared. Now, what many of you will already know, of course, is that this integral is actually just equal to arc sine of x plus c. That's just one of those facts that you kind of need to know, but I often like to start with an example where we know the answer so you can see how we get there by this particular method, and then of course we'll do more complicated examples. So the way you would do this is, what we want to do is set x equal to sine of theta. And I'll show you how we choose what to set x equal to. And having set it up that way, we're now going to differentiate both sides. So dx is going to equal cosine of theta d theta. So that makes sense because the derivative of sine is just cosine. All right, so now what we have to do is we have to replace everything that you see in this function with, everything you see in the integrand, we have to replace it with one of these expressions. So let's do that. So we'll write, let's see, we're going to say that this is equal to, the original expression is equal to the integral. We have dx on the top, so we're going to replace that with cosine of theta d theta. And then on the bottom, we have square root of 1 minus x squared, so we're going to replace this with 1 minus x squared is x is equal to sine theta, so x squared is just sine squared theta. Now, there's that really important identity that you see again. We know that cosine squared plus sine squared equals 1 is just very, very important, and you can now see one of its forms right there. So this is of course sort of reveals why we chose the substitution x equals sine theta, because we were trying to turn the expression under the radical into one of the identities. So now I'm just going to simplify this, and we have cosine theta on top, and on the bottom we're going to have the square root of cosine squared theta. Don't forget the d theta, by the way. That's a fairly common mistake. I just made it, but you have to make sure that you keep that you keep all the dx's and d thetas straight when you do this, or you're going to make a mistake. So here, we'll simplify on the bottom. We now have cosine theta d theta on top, and the square root of cosine squared is just cosine of theta. And then that gives us, now we cancel these, and we get integral of d theta, and the integral of d theta is just theta. The problem is that we need an answer in terms of x, not in terms of theta. You can't just finish one of these problems by just answering it in terms of theta. So if x equals sine theta, in other words, that just comes from right up here, then that means that theta is equal to arc sine of x. So I can now continue this problem now that I know what theta equals. That gives us arc sine of x, and then of course the hardest part of the problem is the plus c, and we're done. So that's the way that you would solve this problem by trigonometric substitution.